Hi guys, welcome back to Mrs. Hills' geometry class in my kitchen. We are going to just do a quick recap of what you learned on Monday in 11.5, and then I'm going to go ahead and get you started on both 11.6 and 11.7, and you'll see that they're very similar, so you're not going to learn a whole lot of new information. But what we talked about in 11.5 was how to find the volume of prisms and cylinders. So I went ahead and found some examples around the house of prisms and cylinders for you, just in case you needed reminded of what those look like. So prisms and cylinders are kind of related because they both have two bases. So this is a cylinder. This is a good example of a cylinder. These are just like blocks that I found. So they have two bases and they're both circles. And then this is a rectangular prism. So it also has two bases, which makes it a prism, and then all of the lateral faces are rectangles. This is a special type of prism called a cube because all of the faces are exactly the same. Okay, and then this is the one I really wanted to show you. A lot of people confuse this for a pyramid, but it's actually just a triangular prism. So it's got two triangular bases, okay, and all rectangular lateral faces, which makes it a prism, not a pyramid, okay? So when I say that we're learning about pyramids today, we are not learning about this. We already learned about this. This is a prism. Okay, so what we're gonna do today for 11.6 and 11.7 is we're gonna talk about how to find the volume of cones and pyramids. And then I'm just going to share with you some extra information about volume in general. And some of it you kind of already saw if you did the 11.5 Big Ideas math assignment. So you're going to see it again, and I just want you to know a little bit more about it this time around. So first things first, and we would have done this in class, but you're just going to, you can do it at home if you want to. So if you want to participate, you can gather the supplies, pause this video, and come back to me. So what I have to best give you these formulas is a bag of rice. You can also use water, beans, just like anything that you could fill an object up with. And then I have a cup, which it's Christmas. So I have a cup. This is going to represent our cylinder. And then I had a second cup that I made into a cone, and this is going to represent our cone. The important thing is that your cone and your cylinder have the same height and have the same base, okay? So if you have something like this lying around and you want to do this with us, that's fine, or you can just watch. But what I want to do for you is I want to show you how a cone or how a cylinder volume relates to a cone volume, and then the same thing is true about a prism and a pyramid, okay? So it might get a little messy. So what we're going to do is we're going to fill this up with rice, and then I'm just going to dump what I can in here, see how many times I can fill the cone up with this amount of rice. Okay, so you're gonna need like a dumping station too. So pause now and go get your stuff if you wanna do this with us. So I'm gonna keep going. Okay, so I'm gonna go ahead and fill up this cup with rice. And I'm gonna try not to spill any, because I don't wanna go to the grocery store to get rice. My dogs will eat what falls on the floor. Okay, I think one more scoop of rice should be fine. Okay. Yeah, I'm gonna put a little. Okay, sorry guys. I'm trying to make this as perfect as I can. Okay, so this cup is filled to the brim. It's as close as I can get it. Okay, it's filled with rice. So we are going to dump this rice into the cone, and see how many times it fills it up. And is it an exact amount, or are we going to end up somewhere in the middle? What's gonna happen? Here we go. So here's one fill time. And this isn't perfect, okay? But it's gonna serve the job well. So I filled this up relatively to the brim one time. This is now that full. So one time full, dumping it out. Let's do it again. Two times full. And then I'm dumping it again. I know you can't see me, but I'm dumping it again. And that's about 3 times full, okay? The reason it didn't work out perfectly is just because this is not a straight cylinder, because it tapers in, okay? But what happened is that 3 of these is the same as 1 of these. And if that didn't work out perfectly for you at home, just remember we're kind of working with what we got here. So, but 3 of these cones is 1 of these cylinders because they're the same height and they have the same, I forgot there was rice still in there. It's fine. And because they have the same base radius, I'm making a mess. Okay. So that would be the same for a pyramid and a prism as long as they have the same height and the same bases, like congruent bases. So what I'm going to do now is go ahead and pause this video and post a picture of an example of the formula that you're going to be using, as well as just examples of the formulas being used. But pretty much what I'm getting at is that a cone formula is 1/3 of the cylinder formula. So instead of just capital base times height, we're just going to throw a 1/3 in front of that, okay? So let me find for you our formulas and show you what we're doing. So this was our formula for prisms and cylinders. All we're going to do is now throw a 1/3 in front of it, and now we're going to call it pyramids and cones, okay? But everything else stays the same. Everything else stays the same. Okay? So stay tuned for some examples. Okay, the next thing I wanted to talk to you about is what happens if you have 2 similar 3-dimensional figures. What is their relationship between their volumes? So we talked about this when we talked about area, and these are some of the things that we talked about in class, okay? And I'm going to kind of write these down as we say them. So if you have 2 figures, let's just say they are squares. This is really putting me to the test here. Okay, so these are squares and they are similar. And we'll say this side length is 3 and this side length is 9. So what would the scale factor be between these 2 shapes? It'd be 3, because 3 times 3 is 9. So the scale factor, if we're just looking at side lengths, is 3. But what if we looked at areas, okay? So what if I wanted to know the area scale factor? Well, if you remember from what we talked about in class, area is 2-dimensional, so the scale factor would get squared. So the scale factor for areas would be 9, because this area would be 9, and this area would be 81. And 9 times 9 is 81. So 3 times 3 is 9. That's our side scale factor. But 9 times 9 is 81. That's our area scale factor. But what if I took it a step further and did volume? What is our volume scale factor? Okay, so all I'm going to do is make these three-dimensional here. Okay, so now we have three-dimensional cubes. This would be a 3 by 3 by 3, and this is a 9 by 9 by 9. So their volumes, well, this volume would be 3 times 3 times 3, which is 27. So this volume is 27. This volume would be 9 times 9 times 9, which I just realized I don't know that off the top of my head. Hold on. Nine times 9 times 9. I'm back. It's 729. Okay. So this volume is 729. So what's the scale factor to get from 27 to 729? Does anyone know? I didn't think so. Okay, it's fine. It is the same as your original scale factor cubed, which is 27. Okay, I know that's a lot of numbers. So here's the main idea. One-dimensional, just the side lengths, is your normal scale factor. When you talk about area, you're switching to 2 dimensions. So your scale factor gets squared. When you switch to volume, you're talking about 3 dimensions. So your scale factor gets cubed. Okay? I know this is backwards on the screen. I'm going to take a picture and insert it here. Okay, and the very last thing I wanted to talk about in this video is what is a composite figure. So I think you saw that on your last homework. It was like a cube with half of a cylinder sitting on top of it. So that's what a composite figure is. It's just finding the volume if you have like multiple figures and it looks like they're glued together. So just know it's not, don't overcomplicate it. You're finding the volume of each separate figure and then adding them together. That's it. Okay, so I will post an example of that done with work shown here. And that's all we got. So here's what you're going to do. You are going to start slow, and you are just going to do a worksheet that goes over volumes of cones and pyramids, okay? So just topic number 1 of this video. And then once you feel like you have a good hold on that, you can jump onto Big Ideas Math and try that assignment. And that will review your cones and pyramids, or oh my goodness, cones and pyramids. Okay, cones and pyramids. And it will also cover similar 3-dimensional figures and composite figures. Okay, and then on Friday, you will be taking a quiz on Canvas that goes over all of the volume things that we learned this week, okay? I am not going to make it long. I am not going to make it harder than what is necessary for you to know, okay? And then for Bellworks, start expecting some volume air test prep questions, all right? They're coming your way. Thanks for participating in week number 2 of online learning.